So I want to thank Data Science for hosting us today. So we have, Jared. Thanks for hosting us. Appreciate it. Just a few quick announcements. Big Data Day LA is coming up August 5th. We almost sold out. Probably maybe the last, last 1% is remaining. So if you haven't signed up, better sign up today before it goes out. Once it's out, we're not going to open up anymore just because we're already completely full. We've already seen the, tracks. We have 8 tracks this year, increased it by 3 more. Several good talks, so feel free to attend. It's completely free again, so make sure you attend that. Just want to introduce Nick who's Director of Evangelism and Talend, and I'll hand it over to him and he can take it forward. Thanks, guys.
Perfect. Thank you. Just a test. Can you all hear me without this? Perfect. All right, so thank you all today. I know that most of you are probably skipping out 4th of July tomorrow, so coming out tonight means a lot. As mentioned, I'm Nick Pieta. I'm Chief Evangelist here at Talend. Just a raise of hands, who's heard of Talend before? Okay. All right. So for those of you who haven't, Talend is essentially a code generator for big data pipelines for data engineers or data scientists to be able to get connectivity to all their different types of data sources, get it to the right place so they can start using their models to actually solve problems. Today, we'll talk about an interesting subject, which is essentially how various sports industries are actually taking data from on the field and having an impact. So to start this off, I'm going to give you a teaser because there's a camera in the back, but does anyone have a sense of what that number is? 4.5 trillion. Oh. Events per game. No, actually, it is frames per second. That is the fastest camera in the world. 4.5 trillion frames per second. Right? Which, when you look at it, we can only see about 60. So if you do the math, that's about 130,000 years just to go through. Now, fortunately, the 4.5 trillion, that's used to identify the point of combustion inside chemical reactions. Right? They're certainly not using 4.5 trillion to figure out if it made it to the goal line or not. But, in itself, represents a big data challenge just from one camera. Right? Now, why I like talking about this subject is because every sports industry is doing something with visual analytics. Right? And we'll get into how you can build a pipeline to solve some of these challenges. But the fact is that every organization has found some way to get valuable information out of this. Right? So while we're speaking about just sports today, the use cases that you see on the back are active customers either I've worked with or companies worked with in many different ways. So you got Disneyland right down the street. Those cameras are tracking you, figuring out where the congestion lines are, and finding ways of offering promotions within the theme park to get you to spread out the crowd. Right? Really cool thing there. Obviously, you have smart cars, smart city, all of these initiatives that are going on inside of LA. Very interesting ways that they're starting to take this information. Now, I don't mean to discount sports at all. In fact, the numbers I have at the bottom are pretty astounding, right? So what we'll be talking about today is the English Premier League. The guy who originally built this is from France. I'm sorry, soccer is a lot more important than football, so we'll get them fixed. But essentially, just the United Kingdom alone in taxes brought in a significant number, right? 1.3 billion pounds, which is 2 billion US, just in tax revenue from sports. Right now, that's the more nice way of putting it. If we take our bottom number, which is essentially $95 billion, that's how much was spent gambling on the NFL this year, right? I would just like a fraction of that for whatever I want, just 1%, right? But if you just were to take that industry and turn it into a company, it would be number 1 on Forbes' list, right? That's a significant amount of money that's being invested. So of course, everyone is trying to figure out how to get an edge, right? So, and we'll talk about the example that we have later, but in many cases, finding the small differences in how players are acting on the field can be the difference between winning and losing a game. as we talked about today and bringing up how to build these pipelines, so I'll talk about two areas. So first one is, how do I get that video image? Like, how could I actually get it into something that I could actually use in my data models? And then the second part is, all right, how do I build a pipeline that could ingest that data and actually create results? Right? So the first section, as we kind of talked about, is that visual side. So the first question I ask when I work with customers that are trying to solve this challenge tends to be, what are you really trying to solve? Right? With your model, with the program at best. Am I trying to identify, in a particular case, it's a car? Right? So I have these two images, right? Which one do I actually need to solve the problem? Is it that I'm trying to identify cars on a highway to get a better understanding of the congestion? Well, I can probably figure out that that's a car, right? Now, if I am working for Ford and I want to know the ratio of Ford models versus Chevy or GM on a particular highway to help them then identify what type of localized promotions they need to do, probably going to need the picture on the left. The reason I bring this up is that this fundamentally changes your entire pipeline, right? Understanding how and what you're going to do with this data. So the flow of this, and we'll kind of talk about how this works and the types of things that you might be interfacing with if you were trying to build this yourselves. Right, so just a raise of hands, data engineers, data scientists, stuck doing both? All right, so some of this will be helpful for some, and I'll try to make sure I get some of this other stuff into the analytical side, but this is actually on a timer for some reason. All right, so let's get here. I don't know why it's timed. Okay, so the first piece of this, which is I have this camera, and I need to figure out how I'm going to collect the information. Now, all right, I think I know what's happening here. All right. How many techies does it take to figure out PowerPoint? So the big challenge comes in collecting this data, right? So as I mentioned before in the image where I had that blurry car versus the very crisp car, one of the biggest challenges with video analytics tends to be the collection of that data, right? So 4K video, which is what everyone probably has at their TV at home these days, the amount of data that's being pushed by your ISP provider is about 150 megs per second, right? That's a lot for a single camera. A lot of times where we've worked with customers, this might make sense in LA, it's not gonna make sense in Bartlesville, Oklahoma. And I've been there, I know it won't. The idea that because I need that crisp picture, I might have to deal with those types of concerns, which means in areas where I might be deploying my models or the whole project as together, I need to be aware of this. The FCC is saying at this point right now, most rural areas can do about 2 to 3 up, right? So I'm not getting anywhere close to that type of resolution if I'm trying to push all of this back home to run my models on. So as we're putting this together, we'll talk about where some of this resides. Now, I mentioned, I'm gonna move out of the way, this, is that one camera at 4K, and by the way, it's actually 150 up, not 150 down. So we're already dealing with almost 100x need in certain areas. That was a single camera. Most NFL stadiums have 20 to 30. So another big data challenge in terms of trying to collect that data. I can tell you the last stadium that ran the Super Bowl, they had a server of about 150 different rack units, right, with 12 in each rack, trying to just collect that information. And that's only internal to the NFL. Then you have their affiliates, everyone else trying to collect this data. It becomes a significant problem to try to push and move all of this in any kind of cloud situation. So I think we could say at this point, at least the collection and essentially codecing of this information is going to happen as close to the source as possible. Now, this will change, right? So there is a new codec that's coming out, I think it's 465, Right now it's 464. We're seeing about, you can compress it and get at least half the size of what it was previously with less loss, which will mean that as we move further along, we will find ways, the technology will catch up where we'll actually start being able to build models that can take advantage of full crisp 4K video. Now, I bring this up because there are a ton of use cases, and we can talk about some of these if you're interested in why companies are looking at this. But just to kind of name a couple, which you wouldn't think, we've worked with companies that are using drones to scan fields for farmers to get crop yields so they can do better risk models, which I'm all for finding reasons to buy a drone. This is pretty interesting. We have cases where we have even just local college track and field using these to help better predict their run movements, to figure out how to get another couple seconds off their 400 time, right? Which I have not run a 400 in a very long time, but I'm sure that there's money in that. So with that in mind, right, so we now have this either raw or codec video, right? Still again. All right. So the big piece that we'll talk about today, and previously before I started, we used to just kind of gloss over this piece, but we'll talk about it and we'll show you how you can build it. The key for you guys as you're getting this data is you will never really get raw video or even any form of a video to do analysis on, unless you are a company that is building this. And I have to preface this because last time I presented, people are like, no, you're wrong, we're doing this. And so the idea is that most of the time, the codec and conversion into either XML or JSON is done by the hardware manufacturer. Right? So when you get this stuff in place, they'll give you a transformed feed so that you can just collect this information. There has been some work on trying to standardize the output of this, but as many of you have worked with a standard before, it never really pans out. Right? HL7 and EDI are just terrible. And they're trying to figure out how to handle this type of stuff for patient information. Now, actually, one more piece to call out before we'll talk about it. There are plenty of companies today that are trying to build libraries for you to do this, and we'll use an example of what Google's offered, but Google, Microsoft, IBM, a couple others. I think last time I checked there was some 30 APIs to help you collect information. A lot of those tend to be basic classification, like is this a face, is this not a face? A lot of them shy away from facial recognition because it's creepy. We'll be using that today just because it's an interesting aspect of this. But again, trying to identify these out-of-the-box libraries that you might be able to use could identify your person, but they're not going to necessarily give you as much to be able to identify two different people. So understanding, again, what is the challenge, what you're trying to solve, will help you define and build these pipelines. Now, the last piece I like to call out of this, because as you kind of seen as I'm talking about this, a lot of this happens as close to the source as possible. All right, there must be a timer on the back of this. I don't know if I can set that up. This whole process, because it is going to be as local to the collector as possible, needs a way to phone home, right? So most of the time you have two types of technologies. You're either going to have REST-based service or you're going to have messaging. It depends on what you're trying to do with that data after the fact. I'll send you guys a link. There's a good conversation around microservices and how you can apply machine learning models to that. That type of information is beneficial for this as you're trying to put this together, mainly so you know, hey, where is this data coming from? How old is this data? Because the volatility of that is very important when starting to look at this type of stuff, especially as the volumes of the frame per second modified. You're going to have to identify in your pipelines when to cut, when to throw out that piece of data, because you know that there's another frame coming down the pipe. A lot of the video analytic APIs do frame-by-frame analysis, which is causing problems. Someone did some test where they added a picture of a tiger in the Google Visions API, which didn't make sense, and yet it caught that there was a tiger in there. So a lot of the data that came back was wrong. Understanding that right now there isn't a lot of intelligence in the APIs as to the difference between frames to the left or to the right in terms of like the time to help kind of aggregate the thought process. I'm not there yet. and we'll kind of run into some of that. So, all right. So we've kind of talked about the challenge of how do I collect this data, what's it going to do? I'm going to now get into an example, and to do that, turn this back on, I'm going to ask everybody to get real close. Because what we're going to do is I'm going to run an example of a pipeline that I built, kind of following that same process, where we can take a picture, and I'm going to there we go. All right, so I will talk about what this is in a minute, but to get the process moving, why don't we get everyone together? What we're going to do is I'm going to use Twitter as a vehicle to get a picture to Google Vision. And we're going to build the pipeline using Talend, and we'll walk through how you could do that. So shameless marketing on my end, really cool demo I'll show you on yours. So maybe about there. We'll see how many faces Google Vision can actually pick out. Right? All right, everybody in. 2, 3, 2, 1. Exactly. Look happy, because it will try to figure you out. So, real quick, solving this problem, because I don't really have a dedicated backbone to push this out. Why not just use Twitter as a means to an end? Yeah, you're done. You can go. I know you don't want to be that close to each other. You can go sit back. Get to know each other. Ask a question. Come on. Right. All right. I'll post that, and I'll propagate through. So, as we kind of mentioned before, Talend is a code generator, right? And so, if I'm trying to build Spark or basic data integration or maybe microservices, I've been a coder for 8 years. I've kind of gotten past how many times I have to write connectivity statements to Google, Microsoft, Salesforce, wherever the data exists. Most of the time I can't just copy paste. There's always some huge difference. So I don't want to code anymore. I see the value of code generation, right? The ability to run this as natively to the API as possible, but I don't want to code. So why I joined Talend was essentially this, right? The ability to define my job in a graphical way that mostly as you're kind of reading this, you're kind of seeing what I'm doing because I've named it correctly and you can follow the lines. But it's essentially a Spark job that allows me to connect to Twitter, pull down tweets, massage the data, get it into the right format, because essentially it's a JSON file that comes out, get the relevant information, which is in this particular case, hey, where's the image located? And then I reference, actually got to scoot down a little bit, here, so I'm grabbing the image. Holy cow, too much stuff up here. All right, so I can grab the image here, which is right around here. So I actually keep a copy of it. Our T-map, so really interesting way of just how I can mess and modify stuff. Because this is writing either Spark, Scala code, or Java code in the back, I'd have the ability to do some massaging of the data, if you will. And in Talend, the way you do a majority of that is through what we call our T-map. So whether I'm trying to filter data, create different pipelines for different threads to run that data concurrently, whether I'm trying to, in this case, define a body for a REST call, I can do all of that here within that. And so then here, essentially, is the REST call that I just make to the Google Vision API. And then I'll log it so we can see it on the screen and get some output out there. So if the demo gods are with me today, we'll run this out, and we'll get to see it come back. Right? So found some tweets, got a result. So as I kind of mentioned before, right, I have now this giant JSON file, which you can see here, about all types of information about facial recognition. Now I can start applying my models in my downstream process. Now, this is very boring because it's just a text screen. I am not a UI developer, so I will rely on Google to just do this for me. So as you can see, I was testing it before with 2 people. Let's pull down the picture I just took. All right, so right, and they have a nice little UI that kind of comes through here, and so as I mentioned, still kind of new. Only caught about 3 faces, right? Right, so now what I see is face number 1 doesn't seem very happy, so I gotta have to work harder in this back half. But the ability to essentially take this information, in this particular case, this is why I do a whole group and not individual. Google's API limits, if you have just a single person, it won't do facial recognition. If you have 2 people or a ghost, then it'll pick up. It's often crazy when you just take a picture of yourself and then it finds another face behind you. That's kind of creepy. But in this particular case, if I were to go down, I can actually see different characteristics of their roll, tilt, what's the difference between nose to eyes, all the information that you actually need to do facial recognition. You have to have 2 people in a picture. Now, one of the interesting things about this is this, right? So not only did it pick up facial recognition, it also then used machine learning in the back end to identify that, hey, probably talking or speaking somewhere, right? And so actually we were talking about how, I was reading an article on the way here about how Snapchat, marketers aren't going to Snapchat. And when you realize the potential of the data that exists around images, there's no better way to classify an individual than by the pictures they take. And so here would be an interesting way of classifying the users that it was able to find that, hey, they like to listen, they're interested in tech. How could we promote maybe like a Galvanize or something else like that, or like even datascience.com, where I know that they're here, I know I could promote to them. Right? This type of information is from just a picture, right? It knows where we're at. Any questions about that? Afterwards, we can take as many of these as you want to try it out. The most I've gotten is about 12. Which is, it's, so depending on, and this would come back to the original point I mentioned of the picture, right? If I was taking a wide angle lens that had a little more, pixels behind it, I'm sure it would pick up more faces. My camera, not so much. Yeah. All right. Okay, so we talked about the data pipeline for collecting that. Now we can talk about what I'm sure most of you are interested in, which is the analytics behind it. Right? How can I do stuff like this? So the actual goal, as I mentioned, being a French company, they like the English Premier League. All right, I will fix this. But essentially, one of the biggest things we kind of talked about, especially in the English, I'm going to fight this all day. Here. Yeah, I didn't treat it nicely. Apparently, forgot to take.
Top center.
Oh, there we go. Between that and it also thinking I am a kiosk. All right, so there we go. Thank you, guys. So the use case that we were working with in this particular case is one of the English Premier League teams trying to identify where their teams were in terms of their pain per end as well as energy thresholds, right? Fascinating about soccer is, and sort of hockey, is that most of these players can play up until their 40s. The gas tank's a little limited when you get towards that age, so understanding their key players when they need to take them out, because certainly there's, from a revenue perspective, the high quality players are going to bring the players or bring the fans in, but they're not necessarily going to relate that to how their on-field performance. And so what they were trying to do is essentially, because they got that file, as we mentioned, from the hardware vendors for the cameras, they wanted to identify, all right, look, is this guy dogging it, or is he tired? Do we need to pull him out? And so identifying using a classification model, which in this case we used a random forest model, just to identify, are they resting, are they walking, are they running, and then within that, an average across those types of categories to figure out is their performance slowing down as time progresses, was essentially what they needed to do. Now, how they did it is different for each one. So as I mentioned, the NFL Zebra case, which is their platform for all this, they have RFID chips, so they know exactly where everything is. English Premier doesn't do that. They haven't sewn anything like that into their jerseys. And so they essentially get X, Y, and Z coordinates for every player at 30 frames per second, 25, 30. And so that's the information they're getting, and so then they know the difference that's going in, and so that's how they're able to then classify and identify which players they need to take out. All right, so we talked about this part, right? How to get that information. The architecture that they went with was essentially this. So we'll talk about Kafka, Spark Streaming, but essentially they just wanted a little web page on their tablets so that one of their assistant coaches could sit there, monitor the players, identify what's going on, make suggestions to the coach not listen. So real quick, before we kind of go into some of the architecture behind this, has anyone played with Kafka before? Right, or heard about it? LinkedIn just made it, yeah, exactly. A lot of times I just want to cover this, but essentially messaging queue that they're going to collect that information. Because it's real time, that's generally where most of our customers use a queuing architecture as opposed to just REST calls, because they don't want to be blocking on the source side. And then I'm sure everyone has Spark background. I don't need to cover this. Just to rate 1.6, like Spark 1.6, Spark 2.0. Anyone on 2.1 yet? Okay. All right. So just getting a sense of who's doing what. It's some interesting times right now with data sets, right, versus RDDs. I say that because we'll show you some of this, but so how do we actually build it, right? So again, back to my code generator in Talend, it's a multi-step process, right? So in this particular case, if I were getting that file either through a message queue from the upstream source, sometimes they just use SFTP buckets to collect that information, so I can just kind of read the file, do some calculations on the fly. Now this is all run in Spark, and then set the period and then start processing it, right? I can load this information. So that's kind of the first half of it. Then, because I'm going to have multiple subscribers to this Kafka queue running this, I have this Spark job that I've defined, right? Where essentially I set the batch size and the window, right? So with Spark Streaming, you have those windows as to how much you want for those micro batches. So I can set that here. Then once I get the file, it's very easy whether you're using JSON, XML, Avro, Parquet, whatever type of format you're working with. It's really easy just to extract it and start working on it on a name value basis. I can normalize each player as I'm working through them. So I was getting a jersey number, I'm going to switch it over to get some more information about who they are. I can replicate it because I'm actually caching this local, as well as then what you'll see down here was that they wanted to just push it to MySQL so that the web page could connect to it. Now, the interesting thing about this is while you've just seen, you know, essentially this job, if I really wanted to, because and we've kind of talked, I know if it wants to work. There we go. So I can switch to code view, right? And it generates all my Spark code for me. So if I wanted to do an 80-20 type setting, or even at a minimum, I didn't want to worry about the connectivity to all the various different sources. I could use this just to provide the connectivity parameters, and then just export this out and just start hacking away, right? Talend also provides you the ability within that graphical interface to just what we call T-Java, which, or then in this particular case, let's say you've written your models in PySpark and I just want to execute them, so I want to just collect the information, put it in the file directory, then after that call my PySpark model. Let me do that too, right? And we have many customers that do that as they start operationalizing stuff. Now, for you data scientists out there, for the love of God, log information in your models. I can't tell you how many times I work with data engineers that have to take this apart and then just operationalize it, so please. So with that in mind, right, in this case here, I've got that information. I've run it through. We have another process in the background that I can kind of pull up that runs the actual random forest model. that aggregates across this. But with the fourth job then being, right, so each one of these steps is just, hey, what was really fascinating about this is essentially I have a REST call that the web page I'm making is, and I define my entire REST service in Talend as well. It just generates the code for you. Right, so if I'm running this all together, which it's been running in the background, so let me see if I need to start some of this back on. That's running. Just populate some data so you can see what's going on with it. All right, it's there. Now this is still running, so you can see some of that data is populating in, which means if I go to the dashboard, which is a copy of what they built, all of a sudden now I have real-time data that's being analyzed and aggregated. So as we kind of talked about, this is the distance that they're working on versus various different players and speeds, and identifying on average where they used to be. So as a coach, I now know when I need to pull my players. Right, so it's very simple to do, and in fact, the use case that we built this for that team, I mean, we got this done in about like a week. Right, now they had a lot of that data already, but the key of this is the time savings that tends to happen when you don't have to write the code. So I know for a lot of you, you'd be rather spending the time building the model, less time in the code to get all the data to actually validate the model. This is what Talend does, and this is what Talend does very well. So, any questions about that? Yes?
How accurate is the real-time data?
So, depending on the number of cameras they have, increases the accuracy. For NFL, they only have 30, and that's usually because they are RFID. I think EPL has about 60, and so when you do the 360 view of that, the X, Y, and Z coordinates are pretty accurate. But yes, it will largely be dependent on if you're trying to do a three-dimensional space. Same thing like when you're trying to triangulate cell phones. The more pieces you can ping, the better it will be. In a stadium, yeah. Yeah, and those are the 4K version of those types of things. So it's amazing when I go and eat a hot dog and a beer and you realize that it's an entire data center that's sitting underneath you to collect this information. Cool. So if you don't have any questions, I have a couple pieces here to kind of talk about after this. And I know a couple of you have shown interest. So everything you've seen me build here is essentially, we have a 30-day trial of the sandbox. And it gives you connectivity to MapR, Hortonworks, and Cloudera. They're all in Docker containers. Even those three distros like to use ours over what they built because it actually works. I can tell you how many times I've worked with a sandbox that you have to do a lot to get it to even start. Ours works phenomenally. In that, you'll see this use case that I provided. I know I saw a couple people were interested in a real-time recommendation demo using Spark, where they're building one. We have an example that you can just figure out just copy this, or do the opposite. Outside of that, our team and the community that we have is pretty large. We have on our forums, and they're very task-oriented about building either Spark jobs. 80,000 people a week, they come in. Of our software, right, and mostly our open source tools. So even at a minimum, our big data open source can generate scoop code for you. So if you need to just pull stuff off and get it into HDFS so you can do whatever you want, you don't want to write that, have at it. The Spark stuff, if you want to try to build it and test it, you can do that with the trial. Wow, one of the really interesting things about this is outside of just question and answer in the events that you see where we're at, we are kicking off this week or maybe next week a use case discussion area. So things like IoT, healthcare, for HL7, all those different types of conversations, we're having those as well. We're bringing industry leaders in to have that. So this type of thing that you've seen me talk about will be an area for you guys to, if you're interested, even just alert, you can find information about what types of use cases are out there that people are trying to apply data science techniques to solve. For those of you that have worked with Talend or even are using it in our open source capacity, we have an award ceremony that's going on right now. We're collecting these use cases so we can talk about them. Goes to charity. Would love to talk about it. I manage the open source community on Laura. So we'd love to talk to you guys about what you're doing. Or I actually feel a lot of the cooler use cases come out of the open source community. So feel free. But yeah, with that, I can give you an hour of your time back. I don't think the kegs have been killed, so thank you. Here, I'll just put it back on.
Taking questions?
Yeah, of course, yeah.
I'm just curious, like the thing you showed, how dependent is it on Spark and Kafka? Like if I want to use Blink instead, is that something that is like plug-in, or is this wired into that
so
particular stack?
interestingly enough, we are actually jumping ahead of Flink and going to Apache
Apache what?
Beam. So for those of you who haven't heard what Apache Beam is, so Spark Streaming and Flink are kind of the two churches of real time at this point. Which one you want to use, there's different ways of looking at it. Apache Beam essentially takes the best of both worlds. So you have a single code base, and then you can create what they call runners, which execute either in Spark Streaming or in Flink. So you don't have to, you get both, because there's cases where Spark Streaming makes sense, there's cases for Flink. And so we are about, I'm going to turn this off. So I have to get in specifics, so like, is it in fact that like just maybe the columns are changed, or are there different errors?
If it's a connector, you connect to third-party data source.
Right.
You make changes, you
Yeah. Oh, that happens all the time.
Yeah, so
I mean,
if it's a connected to the connector, what guarantee is that the changes will keep up to date with it?
right. So there's two pieces to that. One, we are in an interesting situation where actually our community tends to update these things pretty quickly. That being said, because you have the capability of changing it yourself, if you get into a situation where you have to do it, you can. But you're right. I mean, generally, I can't tell you how many times Marketo has changed their underlying scheme structure. I think they're on version 6, probably. It happens a lot. We try to make sure that we have the capabilities where if you're using a community component, like we can give you some help. As we mentioned, there's 80,000 people that are on our community site. A lot of our components, our external components, are used. So I can guarantee there will be somebody that can do it.
And if it does happen, how do you capture this audio? How do you pass the message down that something's happening? Or is it just it stops working, someone's coming like 3-4 days results, so it's not working? What's the mechanism to
Right. So for third-party components, our community site is ready to go. So we're actually in a transition phase right now where we're redesigning that component architecture to help you build connectivity. We will have a new forum that's dedicated to troubleshooting and debugging these types of things. I know that we have this kind of hissing contact between a couple of our developers who do a majority of the open source components where they want to beat each other. And so the other thing is that we do not limit our components to just one. So it's not like if you were to build a Google Analytics connector that you couldn't build one too, right? And so they actually compete with each other on the majority of things to figure out who's got the best.
No, it's not that. It's more like if something happens,
Yeah.
maybe the data source is not available. How do you send? Are you capturing the alerts? Are you doing alerts and sending a message to the user saying that, hey, maybe this file is not available, or maybe
Right. How we submit the job itself, like how we log it.
Error mechanism to capture. How you pass around the user.
Right.
There's some kind of mechanism to board, look at what's going on in this case.
Right. So all of the components push out to Log4j, which I know just came out, they're changing. So you do have the capabilities of collecting the error logs for each one of the components. Now, the quality of that component and how they log will depend on what you do. So as much as I'd like to stand out here and say all of our components on the exchange are perfect, they're not. Generally, anything that you would most likely want to connect to, right? So, you know what they do. I just did a demo where we were taking this information to figure out better ways of promoting certain types of beer brands based on web. These are generic questions. You don't necessarily need to use a specific component. A lot of, I mean, today, a majority of where you're going to get you guys' data sources have some form of RESTful API to connect to. Probably have to deal with it a lot, but the majority is there. So we have hundreds of components that Talend built that will allow you to connect to. Right? So some things like there's a Google Analytics API connect component that a third party built on our exchange. You can still get there with the REST API, but this doesn't give us that doesn't mean we won't build it over time, but we wanted to make sure that the community had the ability to build it. So to answer your question, it depends, and that's largely on like, what do you want it to do. Now, with Talend, like if the job fails, I have an error log, I can create an email that can be sent to say like, hey, this failed, here's the job log that says what it did. It depends on what you want it to do, but yeah, you certainly have the orchestration capabilities to define how that process is.
That can also be a schedule.
Yes. Yes.
And what about dependency management schedule? So you can specify dependency issues.
I don't want to misquote that, we recorded, so let me get back to you on that. But yeah, yes.
So, let me get this straight. Talend relies on components from the community, or does Talend come with components straight out of the box?
So Talend comes with
Talend supports.
Yes. So Talend has components out of the box, which you'll see for any of the big ecosystems like Google, Microsoft, Amazon, Oracle. There's hundreds of ones that Talend builds and supports. I would just mention the community aspect is additional for an additional 1,000. So in total, you're closer to 2,000 components that you have available. So guaranteed, if you're trying to get data from somewhere, it'll be there. But yes, thank you. I should clarify. Yeah.
And relating to the Talend user system, I just wanted to understand what is the architectural difference between the past we used to get a thorough like this get on technologies, so I just wanted to understand what is the architectural difference. It's also the question.
Right. So Pentaho and us, so there's two classifications of big data. Right? So there's Informatica, right, which is the big elephant in the room, and we have, and I'm breaking apart for the case of proprietary runtime engines versus open source technologies, right? So if you, and I'll break that down. If you look at what Informatica provides versus what Talend provides to start, Informatica has, in the field, has their answer to solving the big data problem, right? It barely uses Spark. They want you to run it in a proprietary engine, which is a nightmare. So then you get down to the native code generator. And ultimately, my feeling on this, and it will differ, and I will result in people with more experience, but Pentaho doesn't have the type of the user base that Talend has both in its open source community as well as in its enterprise community. It just outshadows what Pentaho does. Both generate Spark, right? And both are going to have a different opinion on that. I think connectivity-wise, Talend has a bit more than Pentaho, but I mean, you're going to get the same. You're going to get code generation. It's just then I would question how good is that code generation? Right? Our team.
I thought Kettle was an engine-based.
Oh, you said Kettle? I thought you just heard Pentaho.
Kettle is the ETL
Right.
component of Pentaho.
Right. Okay.
And Pentaho's primary business is really BI. That's where all their R&D dollars are going to, so they have the Kettle piece. So Talend, we don't really have that very often unless it's truly a BI initiative. And the Kettle is an engine-based versus a code generator. And with the code generator, you can really, if I'm not mistaken, you can deploy it virtually anywhere.
At the end of the day, it's Spark code, right? So I mean, you can connect Yarn, you can do ASOS, you can do whatever you want. Yeah, you're right. So yeah,
Can you read the generated code? Can you read the generated code end to end for a job if you wanted to?
yeah. So it's real quick. It's still up. Yeah, so I can just switch between designer view and code view, and if it'll let me pull it down. But yeah, I could go top to bottom, everything that's here. the whole thing. And that's what I was saying, like, we do have customers that will do this in an 80-20 setting, where they'll use this to generate a majority of the code. They might go in and tweak a couple things and then productionize it. I wouldn't suggest that, because it's not like you can import it back in. But yeah, I mean, people go and do whatever they want with this. But yes, you can read top to bottom all the code that's generated.
You did have that output Scala?
It is. This actually is in yeah, pretty sure it is. Now, we don't take advantage of some of the like 1.8 Lambda functions yet, but it's something that we can generate into.
One more question.
Yeah. Oh, just one more? Yeah.
A lot of,
I have a question. How can you actually start using it? You said that you guys have a local container?
So the trial of this sandbox, which is where I built the demo out of, is a VM that we have that uses all of the big three distros that are Docker containers. And so if you wanted to, you could download the trial. You could run through some of the use cases that I showed today to build it. We have, because it is designed the way it is, there's tons of tutorials. A lot of our user base built either YouTube videos or blogs about like how to build certain things. So depending on what you're trying to build, you could just download this sandbox and just start building and then connect it to any of the distributions.
There's open source, so there's versions. There's 3 versions of the technology. So if you want to start a single user environment, manually run the jobs, you can download the community edition of your data integration and go all the way down to live. It's full function.
Yeah, so
It's limited to one developer, and it doesn't have any scheduling or administration capability.
and it doesn't generate Spark.
Oh, the free version is not.
Yeah, the free stuff doesn't use Spark. So I would suggest if you really want to play with it, use the sandbox, right? Because it guarantees you'll have the full enterprise class to build whatever you want. Gives you the Hadoop instances right away, so that you don't have to go work with IT to get scheduled time on the nodes. Plus, I mean, Spark runs local, so you can easily kind of set it up to run local before it's on the cluster.
I think we're done. Probably could stay around for
Yeah.
questions.
Yeah, of course.